Let's try solving this question. Find f prime of x of f of x equals x over x minus 1 using first principles, or the definition of the derivative, which is f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x over h. We have to plug x plus h wherever we have x. So in this case, that's here and here. Then we get our f of x plus h. We also get our f of x. Simplify the numerator, divide by h. Then the idea is to get h out of the denominator. So as we are simplifying, that's the goal in mind, to get h out of the denominator. Because if we plug 0 into the denominator, we get division by 0. So that's the aim, to get h out of the denominator. With that in mind, let's get into it. Okay. Our f of x is equal to x over x minus 1. Our f of x plus h is equal to x plus h over x plus h minus 1. So we get this and plug in the equation. So we say limit as h approaches 0. Our f of x plus h is this one. Our f of x is this one. So we say f of x plus h is x plus h over x plus h minus 1 minus our f of x in this case is x over x minus 1. This entire thing is divided by h. Now limit as h approaches 0. We want to make the numerator a single fraction. So we put these two fractions together to make them a single fraction. But first, let's write x plus h over x plus h minus 1 minus. We write this whole thing. We take this division symbol, this over, and write it like this. This is to avoid keep writing too many lines. Now let's simplify these two fractions. Our common denominator is going to be x plus h minus 1. This other side it will be x minus 1. X plus h minus 1 into the denominator, you get x minus 1 multiplied by x plus h minus x minus 1 into the denominator, we get x and x plus h minus 1. This entire thing is divided by h. And this is limit as h approaches 0. Now let's simplify these brackets, these two, and also this side. We have x multiplied by x, that's x squared, x multiplied by h, that's xh, negative 1 multiplied by x, that's minus x, negative 1 multiplied by h, that's negative h, then minus, let's keep the negative outside, x multiplied by x, that's x squared, x multiplied by h, that's xh, x multiplied by negative 1, that's minus x. This entire thing is divided by x plus h minus 1 and x minus 1. Then this whole thing all together over h. Limit h approaches 0. Now let's open this bracket this side. So we have x squared plus xh minus x minus h. This is now minus x squared minus xh. Now this is negative and negative there, so that's plus x. This whole thing is over x plus h minus 1 x minus 1 altogether divided by h. Now, let's look for terms that can cancel out. We have positive x squared here. We have negative x squared. These two cancel. We have xh here and negative xh. These two as well cancel. We have negative x and we have positive x. These two also cancel. We are only left with negative h in the numerator. So this becomes negative h over x plus h minus 1, x minus 1 over h, and this is limit as h approaches 0. Now, this is divided by, it becomes multiplied by 1 over h in the next step. So this is negative h over x plus h minus 1 and x minus 1. This division, if it's like divided by 1 divided by h, becomes 1 multiplied by 1 over h. This is the same principle we're applying here. And this is limit as h approaches 0. Now notice that this is multiplication, so we can cancel h and cancel h, leaving us with negative 1 in the numerator, the negative and the 1, over x plus h minus 1 and x minus 1. Limit as h approaches 0. Now notice that we still have h in the denominator. However, this h doesn't cause this to be division by 0. Therefore, we can go ahead and apply the limit. We'll say when h approaches 0, this becomes negative 1 over x plus 0 minus 1 and x minus 1. This is equal to negative 1 over x minus 1, x minus 1. We can finally write this as negative 1 over x minus 1 squared. And that is our f prime of x.